So IMath kind of brushed upon nonlinear inequalities, but I just don't think that they dived as deep as we need to because this is going to come up if you ever take calculus. So we're going to talk about where a function is positive or negative, and we're going to do it more algebraically than IMath did. IMath mostly focused on what the graph looked like, which is a good thing to do. If you know how to graph it, you can find the positives and negatives, but I want you to know how to do it algebraically, okay? So just remember that a function is positive on an interval if it is above the x-axis. So we're looking at, let's just say we have a little function. Let's say it looks like this. So that function is positive on those end points. Now, what's interesting about positive on an interval or negative on an interval is the fact that we need to find the points of intersection of the x-axis. So those zeros will help us as well. A function is negative if it is, please put below, that's what I get for typing these, below the x-axis. If it is below the x-axis. So if we look at that same graph that we see here, it would be here. Now, you talk about the word that the function is above or below. The function is referring to the y value. You always need to pick the interval, and a note for that you should write here for all of you is that the interval refers to the x's. So the interval itself refers to the x's. So if I say a function is increasing, that's the y. On what x's does it happen? Is a function positive? The function itself is positive, but what x's does that happen? So the interval should refer to the x's where that happens. Okay. So again, I want to focus on not relying upon the graph as much. I know that algebraically, many of you are stronger than you are for graphing something. So that's why I've always relied upon the algebra. In calculus class, if you ever take calculus in the future, in calculus class, you really have to know how to do those intervals of positive or negative. And sometimes the graphs are so yucky that if we can rely on the algebra, it's just more helpful. Okay. So let's go ahead and talk about what it looks like on a graph, and then that's going to lead us into the algebra of it. So in this one, let's highlight the parts of the graph that are above the x-axis. I did it kind of in this green color, and then in red, I've done and highlighted where it is below the x-axis. So we would say that our function is positive. So that's the words are describing what our function is doing on what x interval. So when our x is going from left as far as we want until it hits a value of 1, and then again from 3 to infinity. So our x values from negative infinity to 1, and then from 3 to infinity, our function is positive. Our function is positive. Okay, so remember, the word is describing what the function is doing. It is above the x-axis. The intervals are always the x's where that happens. Okay, we know our function is negative on what x's? Well, just this little piece right here, from an x value of 1 to an x value of 3, our function is under the x-axis. So we go from 1 to 3. Now, even though 1 and 3 are points on the graph, they are not positive or negative, they're 0. So that's why we don't put brackets on there. Please just use parenthesis notation as you go through this particular lesson, okay? Because if I'm equal to 0, I'm not positive, I'm not negative, I'm kind of neutral. So let's do the same thing for number 2. Let's highlight everything that's under the graph. in red, everything that's over the graph kind of in green. Be kind of consistent there. Okay. And first, let's start out, where's our function positive? Now, our function is positive in two locations. From an x value, that is 1, to an x value of 3. And then again, from an x value of 5, forever, ever to infinity. So that's how we're going to write it. So between an x value of 1 and 3, that's that upper bump. And then also from 5 to infinity. So our function is above the x-axis. Where's our function negative? Well, we have two locations. Let's look at it for a moment. From negative infinity up to a value of 1, our function is below the x-axis. So that's how we'll write that. And then this little wedge here between an x value of 3 and an x value of 5. So there is where our function is positive and negative. So you can see there are 4 distinct portions of the graph. I've colored 4 different things. Our positive and negative should contain 4 separate things. You see how that was done? Do we have any questions about the graphical interpretation of a function being positive or negative? Okay, so what x's will that happen? My x value of between 1 and 3, my function is positive. It's above the x-axis. From an x value of 3 to 5, my function is below the x-axis. So your interval always describes your x. And that happens many times, positive and negative, increasing and decreasing. Those things describe the y, and then the interval always is the x. So that's kind of a way to remember that. Okay, we good there, kind of. Okay, so now I would like to talk about it algebraically. Now, in order for us to solve an inequality and relate it back to positive and negative, we should always have it related to 0, like we see in number 5. So the fact that it is greater than or equal to 0 means that we are going to include the zeros in a bracket, and then we want the greater than 0. We want the positives. So keep in mind what that is asking. Now, if we were able to graph it, we could definitely see what is happening, and we could do it that way. But I want to show you how to find it algebraically, okay? So the first thing you want to do is you want to find the zeros. So a 0 will occur when x minus 2 equals 0 and when 3 minus x equals 0. So you're going to find those zeros, and those zeros happen at 2 and at 3. Now, once you find the zeros, we are going to make what I call a plus or minus chart. So leave yourself a little bit of room. You'll notice I put myself a little room, and we're going to make a number line. We're going to put the zeros we found on the number line. Now, if our zeros are including, we're included only if we have an equal to symbol in the problem. If our zeros are included, please put a closed dot on the zeros. If the zeros will not be included, we'll put an open circle, okay? Just like you would graph on a number line. Now we're going to make this number line turn into what I call a plus or minus chart. There are 2 factors in the original problem, so I need 2 rows in my plus or minus chart. Now we're going to write down the factors to the side. If you left yourself enough room on the left side, put it on the left side. If you left yourself enough room on the right side, put it on the right side. It does not matter. And I'm going to write down each factor. X minus 2 was one of my factors. 3 minus x was one of my factors. Whatever factors were included in the original, we must include. Okay. And then we're going to find what I call test values. We're going to test values in a region so that we can determine, do we get positives or negatives? So you just need something to the left of 2. So if zero's there, if that's a nice number. Something between 2 and 3. So 2.5, you know, there's millions of choices. This is what comes to my head when I first see it. And then something after 3, why not 4? Now we're going to plug these into the factor, and we are going to just write plus or minus. All we care about is our answer positive or negative, okay? Because that's what the plus or minus chart is going to help inform us about. So the first thing I'm going to plug in is I'm going to plug in 0 to both of those. And I'm just going to record, do I get a positive or do I get a negative? If I plug in 0 to the top, 0 minus 2 is a negative. If I plug 0 into the bottom, 3 minus 0 is a positive number. And then I'm going to record what happens when I multiply those things. Well, a negative times a positive is a negative. So that region of our graph would be below the x-axis if we were to look at the actual graph. Okay, now let's plug in 2.5. If I plug 2.5 into the top, 2.5 minus 2 is a positive. 2.5, 3 minus 2.5, that bottom one, if I plug it in there, I get a positive. And a positive times a positive is a positive. That part of the graph is above the x-axis. And let's look at 4. If I plug in 4 to the top, I get a positive. But if I plug in 4 to the bottom, I get a negative. A positive times a negative is a negative. Now, we almost have the answer staring us right in the face, but let me show you how to interpret it. It says right here that we want to get greater than or equal to 0. We're including the zeros and the positive regions. So now on your number line, could you please color in whatever happened to be positive? The only values that are positive are between 2 and 3. So the answer to this is that our function is positive between 2 and 3. And we only put a bracket, positive or 0. I'm sorry. We only put a bracket if this thing included the zeros. It says it can be equal to 0, and that's the only time we include those in brackets. And that's why I colored those in down on the graph so that those are clearly marked as, hey, I want to include those. Now, if we were to check this in Desmos, let me show you if we were to check it in Desmos. All you're going to do is type in your quantity of x minus 2 times your quantity of 3 minus x. And you're going to look for a moment. I had there for a second. You can see, I'm going to zoom in so you can see it a little clearer, is that between 2 and 3, our function is above the x-axis and it equals 0 at 2 and 3, so we include that. So the graph and the algebra should always blend together. If they don't, you did something wrong. You either typed in your equation funky in Desmos, you didn't graph it right, or you didn't do the plus or minus chart right. Do we have any questions about number 5? Let's keep going. What do we notice is different about number 6? What do we notice is different about number 6? Yes.
First off, there's no 0, and second off, it's a square.
Okay, perfect. So it is not factored yet, and it's not 0. So we have to fix that. So it's really great that we notice that. So that one there is icky. So the first thing we want to do is always, always, always relate these to 0, or they're not going to work. Because we're always relating, is it bigger than 0 or is it less than 0? 0 is the key. So we're going to make this x squared is less than, or I'm sorry, x squared minus 1 is less than 0. But it was also noted that it isn't factored. So we have to get it into factored form, and then we're going to do exactly what we saw in problem number 5. I don't know why they're numbered like that. Anyway, let's take a look at how we factor that. That is the difference of squares. That factors to be x plus 1, x minus 1. So once it's related to 0 and in factored form, we proceed. Once it is related to 0 and in factored form, we proceed. So what did we do last time? We found the zeros. X plus 1 equals 0 at -1. X minus 1 equals 0 at +1. We're going to make a chart including those in number line order. This time there is no equal to symbol, so put open circles on the zeros. That will remind us, hey, we don't use brackets this time. This means just that we want the negatives. That means we're looking for the negative regions. So now let's make our number line into a plus minus chart. There were two factors. We need two rows, x plus 1, x minus 1. So the factors you should include are everything that is on the opposite side of the 0. Okay, we need test values. Why not go -2, 0, and +2? Anything in that region will work. It doesn't have to be what I just chose, but those are just nice numbers to plug in, nothing funky. Okay, so if I plug in -2 to both of these, you're just recording, do I get a negative or a positive? -2 minus 1 is a negative. -2 plus 1 is a negative. Two negatives make a positive. That region is positive. Now let's plug in 0. We get -1, which is a negative. +1 is positive. A negative times positive is a negative. If we plug in 2, we get a positive and a positive, which is a positive. Now remember, this time we want to only color in the negative values. The only negatives are right here. So our function is negative from -1 to 1. Our function is negative between -1 and 1. If you were to graph this, this is a parabola with zeros at +1 and -1. The bottom of the parabola is below the x-axis. So anything between +1 and -1 is below the x-axis. The tails are going upward. That's the positive sections. Okay. So if you know the graph right off the bat, if you knew what x squared minus 1 looked like, you know that's a parabola moved down 1. It also answers the question. So graph is always a way to answer these, but I want you to try it with the algebra as well. Everybody good with that problem? Yes. Let me remind you, okay, so if the equal to is in the problem, like if there's a little equal to, make sure to include the zeros with a bracket, otherwise not. If it says like this one, greater than 0, numbers are greater than 0 when they're positive. If it says less than 0, numbers that are less than 0 are negative. So that's all you're looking for. If it's greater than 0, you want the positive regions. If it's less than 0, you want the negative regions. So just always remember that, greater than 0 or the positives. We can even put that up in our little notes here. This would be when our function is greater than 0. This would be when our function is less than 0. So make sure you know that notation. It's very important. Greater than 0 are positive numbers, less than 0 are negative numbers. So just if you know that, you're going to be good to go. Any other questions so far? Okay. Now, your job is to do these for the remainder of class, but I would like to do 9 and 10, probably 8, 9, and 10. Let's do 8, 9, and 10, okay? 11 is bonus, but 8, 9, and 10, let's do those right now. Those are the hardest. So let's start with problem number 8. So again, this isn't related to 0, so that 6x is in the wrong location. So the first thing you always do is you have to relate it to 0, however you want to do that, but in this case, just subtract 6x from both sides. So we get x squared plus 10x plus 24 is greater than 0. So this tells us that we want only the positives. So when we make that plus minus chart, we're just looking for the positives, okay? But remember the first problem we did, it is essential that it's in factored form. Okay, so I don't like the fact this isn't factored. So the next step is to get it into factored form. The factors of 24 that add up to 10 is 6 and 4. So this is going to be x plus 6 and x plus 4. Now from here, we need the zeros. The zeros are -6 and -4. Remember, it's always going to be the opposite of what you see inside there. So in number line order, -6 is to the left of -4. Do we include the -6 and -4? Do we put a closed-in dot there, or do we put an open circle there? At -6 and -4, do we put a closed-in dot or an open circle there? Open, so let's put those on there. Now let's make that into a chart. So we're going to extend those little lines. There were 2 factors, so we need 2 rows. We need to include x plus 6 and x plus 4. So now we need some test values. To the left of -6 is -7. Between -6 and -5 is, between -6 and -4 is -5. And then 0 is a nice number to plug in, and it's to the right of -4, so why not? Now let's plug -7 into both of those. If I plug -7 into the top, I get -1, so that's a negative. If I plug -7 into the bottom, I get -3, that's a negative. 2 negatives are going to multiply and give me a positive. Let's plug in -5. I get a positive and a negative, which is negative when I multiply those together. Let's plug in 0. I get a positive and a positive, which is a positive. Many times you're going to see this alternating pattern, plus minus, or minus plus minus plus. That's very common. Let's color in what we want. We wanted greater than 0. Numbers greater than 0 are positive. So we only want this region and this region. And it's not a bad idea to actually put the little negative infinity and positive infinity symbols on your chart, because then that will tell you exactly what intervals we want. So I colored in our x's that answer this question or that are positive are from -infinity up to -6. Don't put a bracket, that wasn't included. And then put your union symbol, and then I'm going to go from -4 to infinity. So that's number 8. Do we have any questions about number 8? Okay, let's look at number 9. Now they were very nice to us. It's related to 0, check. It's in factored form, check. So even though but it's got 4 possible zeros, okay? So remember, this tells us we want the negatives. Our zeros occur at -5, +2, +1, and -1. Put those in number line order. I need all the room I can get, so that's why I put those at the top there. In number line order, they go -5, -1. Don't space them out evenly. That doesn't matter as much, just as long as they're in number line order. -5, -1, 1, and 2. It is not allowed to equal 0, so I'm going to put open circles on all of those. I'm going to make this into a chart. I need 4 rows. So 1, 2, 3, 4. I got 4 rows. I'm going to put each factor on the side there. Left, right side, it doesn't matter. It's just a little spot to put them. We need test values. So I'm going to test -6, -2, 0, 1.5, and 3. Lots of testing has to go on for this one. That's why I wanted to do this one with you. Let's plug in -6 to each one of those factors. You're just plugging in -6 and saying, did I get a positive number or did I get a negative? If you plug -6 into the top, you get a negative. If you plug -6 in the x minus 2, you get a -8, negative. That you get -7, you get -5. All those are negative. 4 negatives, when they are multiplied together, become a positive. Now let's do -2 as our test value. I get a positive, I get, let's see, I get a negative still. I get a negative. I get a negative. 3 negatives make a negative. I think this is going to go plus minus, plus minus. They don't all do that. The next one we do won't do that, but many of them do. If you plug in 0, you get a positive, a negative, and a positive. 2 negatives make a positive. If we plug in 1.5, we get a positive, we get a negative, we get, what's that there? That would be a positive, and that would be a positive. 1 negative makes a negative. Plug in 3, we get a positive, and a positive, and a positive, and a positive. 4 positives multiplied give you a positive. Now go back and look what we wanted. We wanted our negatives less than 0, so color in the negatives. And our answer is that this long multiplication will be negative in 2 regions, from -5 to -1, and then also from 1 to 2. If you were to throw that into Desmos, you would see there is a bump under the x-axis at -5 to -1, and then another bump under the x-axis from 1 to 2. Those are all through points, so you could make the graph really easy. It looks like a W kind of. And then the last one I want to do is 10, and then you'll have till midnight tonight to finish these up and turn them in. But you'll probably get them done in class. So the reason I wanted to do number 10 is you'll notice that it has squares on there. So that's going to change things a little bit. Not much, but a little bit. So the first thing you want to look at is that I want positives and the zeros. The zeros are okay because we got that equal to. So I can be greater than or equal to 0. The zeros occur at -8, -5, and -7. Let's put those on our number line in least to greatest order. Spacing doesn't matter. We need 3 rows because we have 3 distinct factors. And here is my key for you, please. You have to include the powers. You have to include them. So x plus 8 squared, x plus 5, and x plus 7 squared. Now, what's easy about this, okay, first let's put our zeros, dots, close dots, close dots, close dots. What's great about this, let's think about it for a minute. If I square something, what always happens to the powers? If I square something, what always happens to the powers? If I square a positive, what do I get? A positive. If I square a negative, what do I get? A positive. So these, I don't have to test diddly squat. They're always going to be positive. Now, if it's a cube or if it's an odd power, that we have to do it. But if it's an even power, even powers are always positive. So the only ones I have to test are in the x plus 5. So I'm going to do -9, -7.5, -6, and 0. But something else, I'm going to give you a little hint in a second. Okay, if I plug in -9, I get a negative. If I plug in -7.5, I get a negative. If I plug in -6, I get a negative. If I plug in 0, I get a positive. Do you see how -5 is the 0 that went with x plus 5? That's its 0. Do you see how to the left of it's negative and to the right of it's positive? That's going to happen, okay? So anyway, so now let's put in what we got. Okay, so this is 1 negative, this is 1 negative, this is 1 negative, this is positive. We only want the greater thans, so we only get this region right here. We do include that in a bracket because of the equal to. Our answer is from 5 to infinity. 5 to infinity. Remember, infinity, no matter what, always gets a parenthesis. Okay. So 11 is bonus. I'll check that for you. Remember, they always have to be related to 0 and in factored form. So if you notice, 1, 2, 3, and 4 is ready to go. 5, 6, and 7, you do have to get those factored. Okay. And then tomorrow, we're going to keep exploring this, but we're going to also talk about rational functions. We're going to look at some fractional ones tomorrow. So, but it's kind of almost the same technique. Okay. So for the rest of the class, work on this. try to turn it in by the end of class, then you don't have homework. Otherwise, you got homework. Okay, there you go.